Okay, so for this one, we have to obtain the Bode plot for the following transfer function. So first thing we have to do is have this to be added by 1. So JW times something plus 1, and so on for this one. So the first thing we're going to do is factor out 10 from the top. And this one stays the same. Factor out of 5, JW over 5 plus 1. All of this is squared. Now we can actually FOIL in the square. So this is the same thing as this and this squared. That's good. And 5 squared, that's just 25. Okay, and this is just the same thing as 0.4. So that's all good. So now let's take this to the log of 10. So it'll be log, and this is going to give you your HDB or your magnitude. So log 0.4 plus log JW over 10. Sorry, it's minus 20. Wait, my bad. It's supposed to be 20 log 10 0.4 plus 20 log JW 10 plus 1 minus 20 log JW. Then the last one is minus 20 log JW over 5 plus 1 to the power of 2. And the 2 we can bring down here, so it'll just be minus 40. Okay, and to graph this, we're going to be using this following sheet. But make sure you try and memorize the sheet, because I don't know if you guys are going to be allowed to use it during tests or quizzes. Now, for phasor, obviously, we take tan inverse of the imaginary part all over the real part. So the imaginary part for this is 0 all over the real part, so 0.4. This is just tan of 0, which is just 0. Plus tan inverse of the imaginary part, which is JW over 10. Wait, I'm going to move this here, okay? There. JW over 10 over 1 minus tan inverse W over 1. This one is going to be minus 2 because we have a 40. So 40 divided by 20, that's minus 40 divided by 20, is that's minus 2. Tan inverse the real part, imaginary part is W over 5 over 1. Okay, now let's plot the Bode plot for this. So this is HDB, and this is W in radians per second, and this is in decibels. The y-axis is in decibels. So let's plot this point out. So 20 log 0.4, that's minus 7.958. Okay, so that's going to be represented by 20 log 0.4. Now what's next? Now this one, let's check our sheet. We see JW over 10 plus 1. That matches this one. So at point Z, which is going to be at point 10, it's going to break up and have a slope of 20 and decibels per decade. So n being whatever the power is to this. So at point 10, it's going to do this and then move up from here. And this is going to have a slope of 20 decibels per decade. Decade being whatever's being the thing that's being, how should I say it? Decibel is whatever, something that's increased by a factor of 10. So 1 to 10, that's 1 decade because it was increased by 1 factor of 10. 1 to 100, that's 2 decades because it was increased by 2 factors of 10. Because 1 times 10 times 10 is 100, so that's 2 tens, and 1 times 10, that's 10, and that's just 1 10 that was involved. So this one is going to be 20 log JW over 10 plus 1. Okay, now minus 20 log JW. Let's see. So since it's minus, we're going to be doing this one. And we see at point z, which is going to be 0.1, it's going to intersect through it with a slope of minus 20. So it's going to be like this. So this is going to be 20. Actually, I think I'm gonna extend this out more, because it's not gonna look too scaled. There we go. This will be 20. So that looks good. This is still not to scale, but whatever. And remember, we start at 0.1 because log of 0 is going to be undefined. So we're going to start at the point after 0. So for now, we're going to take 0.1. And then this is just minus 20 log JW. And it has a slope of minus 20 decibels per decade. Now, this is the interesting part. Notice how this is minus 40. And that's the same thing as minus 20 log to the power of 2. So we have n being 2 in this case. So that means everything here is, so pretty much all of these values are going to be being times by 2. So JW plus 1, minus, and since this is a negative value, we're going to be using this one. So notice how it says minus 20 n dW over decibel over decade. It's actually going to be minus 40 because n is 2 in this case. So at 5, okay, this is really not to scale. I'm going to move this here. This is going to be 10. And put an arrow to represent that. So at 5, we have something like this, and then it breaks down, but it's going to have a slope of minus 40. Hold on, I'm going to move it all the way down here. This is minus 20 log JW over 5 plus 1 squared. Or you could just do minus 40. That's also fine. And it has a slope of minus 40 decibels per decade. So now let's make our Bode plot. So we have to first add up our beginning values. So 20 minus 7.958, that's 12.042. So we'll start here. Whoops. Hold on. There we go. And this slope has a slope of minus 20 decibels per decade. So it's going to be going down until we hit 0.1. Okay. Oh yeah, and then let's find the point. What this is on the y-axis. So y2 minus y1 being 12.042 log, because remember, we're not working with radians per second, we're working with decades. So log of this point over this point. So 1 over 0.1, and this is equal to minus 20. So now let's solve for y2. So it's minus 7.958. So it's actually going to stop exactly here. There you go. That looks pretty good. Now, as we continue our thing, we see our slope increases. Because right now, because now we're taking this into account. Wait, sorry. No, never mind. Our slope here is still 0. So that means right now we still continue our thing with a slope of minus 20. Okay? Honestly, we didn't even have to stop at 1. We should have just continued going until we hit 5. 5 is our major change because now we have to take this into account. So we hit 5 here, but at least we now know at 1 we're at this point. So now we have to find a point here because now we have to take this into account. So let's find a point at this region. So honestly, most of these calculations, they could stay the same. We just have to y2 is just going to be 5 in this case. Sorry, 5 over 0.1. Okay. And we get y2 to be minus 21.937. So that's what this point is going to be. And then notice this. So all of this region had a slope of minus 20 decibels per decade. Now we have a slope of minus 60 decibels per decade because we have minus 20 plus minus 40. And this continues all until we hit 10, where then we have a slope of 20 decibels per decade. So that causes this and this to cancel each other out. So then we're just left with minus 40 decibels per decade. So it moves like this after that. Okay, so let's find the point of this, and then we should be done. Okay, so this is minus 40 decibels per decade. So for this point, it's going to be so y2 minus y1. Y1 will be this all over log of x2. X2 is going to be 10 all over x1, which is 5. And this is equal to minus 60. So y2 will be, give me a sec. It's going to be, y2 is going to be minus 40. So this is, if we extend this all the way down, this is just minus 40. Okay, so that's our Bode plot. It's pretty messy, but meh, whatever. Now let's do our phasor one. Okay, so we're going to be working with these tans. Find what they're related to. So this is related to this one. This one is related to this one. This one is related to this one. So let's take a look at these. So JW over 10 plus 1. So this one matches. We see at, so Z is pretty much our point P. So our Z value is actually 10. So at point Z over 10, so 10 over 10, our thing breaks to an unknown slope and then hits 90 degrees at 10 times Z. So Z being 10, so at 100, it goes to 90 degrees. And also, it's 90 times the power. Our power in this case is just 1. So let's draw this. So this is 1, 100, and this is 90 degrees. So it goes like this, all the way up to here, then like this. Hold on, let me draw this more properly. There we go. So that's that done. So this is going to be tan inverse J. It's supposed to be W over 10. I should not have added that J. There you go. Now, this one, we see it's related to this, and it's a negative value. So JW, so it's going to be 1 over JW. It's going to be this one. And we see it should be minus 90 degrees all the way around. So it's going to move like this. Now our last one, so minus 2 tan inverse W over 5. See, this one has a power of 2. So what we have to do is times, so we see this one is the one that matches. So we're going to be using this one's graph. And we see this one, we have to times this by 2. So it's going to be minus 180. So our Z for this one is 5. So 5 over 10, that's 0.5. So somewhere here. And 5 times 10, that's 50. So somewhere here. And since it's negative, so it goes from here, breaks down to an unknown slope, goes all the way here to minus 180, and then starts moving straight like this. Okay. And this is going to be minus 2 tan inverse W over 5. Alright, so now let's draw our Bode plot. So from 0.1 to 0.5, we have a slope of 0. Then from 0.5 to 1, we have a, oh yeah, we should calculate these two slopes, okay? Remember, we don't know the slope values for these, so we should calculate them. So let's find the slope of this. So it'll be y2, which is 90, minus y1, all over log of y2, 100, all over, sorry, of x2, all over x1. Recall we're starting from 0.1, not 0. And this gives us okay, hold on. Give me a sec. I think I might have made a small mistake. Oh wait, sorry, not 0.1. 1, because this from here. Sorry. Yeah, sorry, that was my mistake. There we go. It's supposed to be 1. We started at 1, not 0.1. My bad. So log of 100, okay. So that's 45 degrees per decade. So this is going to be 45 degrees per decade. And then this one, 50 to 0.5. So y2 is minus 180 minus 0 all over log of x2, 50 over 0.5. And let me see what that gives me. Yeah, it's minus 90. So this has a degree of or a slope of minus 90 per decade. Okay, so now let's find the Bode plots. And oh wait, I just realized I made a mistake. Sorry, we should not be starting at 0. We should be starting at minus 90 because it's this plus this, and that's just minus 90. So let me erase that. Okay, hold on. This is gonna be a little difficult to erase. And there we go. Okay. So we actually started from here. So wait, I think something's got erased. Okay. There we go. So from 0 to 0.5, sorry, not 0, 0, from 0.1, because we're not starting at 0, from 0.1 to 0.5, we have a slope of 0. And then from here, we have a slope of minus 90 until we hit 1, okay? Because this is the only thing that's, being added to this slope. And then now let's find the point here. So y2 minus y1, y1 being minus 90, all over log of x2 all over x1 equals minus 90. So let me see what that gives me. 100 minus 117. So this is minus 117.09 degrees. But then from here on, we have to add this and this together. So minus 90 plus 45. That's minus 45. So our slope from here on off is minus 45 degrees per decade. And this is obviously minus 90 degrees per decade. And this is like that all the way until we hit 50. And then from here, let's find the point here that's going to be connected to here. So it's going to be y2 minus y1, which is 117.09 all over log of 50 all over 1. And that's equal to minus 45. And let's see what that gives me. That's y2 will be minus 193.543. So it's actually not going to be here. It's going to be much down here. So somewhere around this point. So again, not to scale. There we go. And then from here, we have a slope of 45 degrees because this is now 0. This is now 45. And that remains the same from 50 to 100 when this has now a slope of 0. So let's find that point. So y2 minus y1, which is minus 193.543, all over log of 100 over 50 equals 45. So let me see what that gives me. That gives me minus 180. So at this point, we're going to go all the way here, and then after that, we just continue at a slope of 0. So this is 45 degrees, and it's connected and at 100, we're at minus 180.